All right, I have three equations that I'm going to solve for, three systems of equations that I'm going to solve for. And then the way I'm going to solve for each of them is going to be completely dependent on what they look like. I'm either going to do substitution or elimination. I would do substitution if one of my equations had y or x all by itself, and I'd do elimination if everything was lined up perfectly and the numbers seemed to match up. Now, taking a look at this guy, I have x plus 6y equals 7, and I have y equals 11x minus 10. What I'm going to do in this case is I'm going to use substitution. The reason why substitution is the way to go for this one, and you could do elimination, you can graph if you want to, but the reason why substitution seems to be the way to go is because y is already by itself. So all I have to do is take the y from the bottom here, which is 11x minus 10, and plug it into the top y up there, and then just take it away. So let's do that. X plus 6. Now, it normally says y, but instead of y, I'm going to substitute in 11x minus 10, and I'm going to keep writing the top equals 7. Okay? Next step, distributive property. I'd say most of the time I have one of these processes I do distributive property. So 66x minus 60 equals 7. X plus 66x is 67x minus 60 equals 7. Add 60 to both sides. And 67x equals 67. One more step for x. Divide both sides by 67. Divide both sides by 67. X equals 1. Now I have half of my answer. The other half of my answer is going to be found by finding y. Now if you look at the original two equations, I have x plus 6y equals 7 and I have y equals blah, 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 blah. If I'm to find y, why don't I just take my answer that I got here and plug that into that y? Because I want y. Y equals 11x. Instead of x, I now know that x is 1, so 11 times 1 minus 10. 11 times 1 is 11, and 11 minus 10 is 1. So since x is 1 and y is 1, I have the answer 1, 1. So again, since y was all by itself, substitution seemed to be the way to go. By doing it, I got a nice perfect answer of 1, 1. Like I said, you could do elimination, you could do graphing, but substitution is the easiest way to go. All right, second problem. I have, again, a system of equations. 10x plus 12y equals negative 22. Negative 6x minus 6y equals 12. My options are substitution, graphing, or elimination. Looking at these, x isn't all by itself up here, y isn't all by itself down here, x not all by itself, y not all by itself. So substitution doesn't seem to be the way to go. Since y isn't even close to being by itself, I wouldn't want to graph either. Since I have my x's already lined up, my y's already lined up, my equal signs already lined up, and my constants already lined up, I'm going to do elimination. Now, looking at this immediately, my x's won't disappear if I add them. Same thing with my y's. However, I have a 12y up here and a negative 6y down here. If I take the entire bottom and multiply it by 2, that'll turn that negative 6y into a negative 12y, and that'll make this 12y up here go away. So let me rewrite the top equation. 10x plus 12y equals negative 22. 2 times negative 6x is negative 12x. 2 times negative 6y is negative 12y. And 12 times 2 is 24. Now what we do is we add both lines. 10x plus negative 12x is negative 2x. The 12y's go away, so plus 0y, which means I don't really need it. So I'll rewrite that in a minute. Negative 22, positive 24, positive 2. So after adding both lines, I have negative 2x plus nothing equals 2. And it's just really a simple one-step equation. Divide both sides by negative 2, x equals negative 1. Halfway done. Now I need my y. So it doesn't matter which one I plug this negative 1 into. I'm going to plug it into the top equation to get my y because I already messed up the bottom here. So I'm going to rewrite the top equation. 10x plus 12y equals negative 22. What I now know is that x is negative 1, so 10 times negative 1 plus 12y equals negative 22. 10 times negative 1 is negative 10, plus 12y equals negative 22. Negative 10 is in the way. Add 10 to both sides. Add 10 to both sides. That leaves me with 12y equals negative 12. Divide both sides by 12. Divide both sides by 12. And y equals negative 1. X is negative 1. Y is negative 1. My answer is negative 1. Negative 1. Super creative by me coming up with these answers where they're all the same. Good job. Good job, self. Yay. Awesome. All right, one more to go. 7x equals negative 21, y minus 28, 5x plus 15y equals negative 20. So I have to decide, do I want to graph? Well, I don't want to graph that. I don't want to graph that. Y is not even close to being by itself for either of them, so that's out of the question. Substitution, well, this x is almost all by itself, so that's an option. Things are not lined up. I know it looks like the x's, since the x's are above the x's, and the same thing with the y's, they look like they could be lined up. Those equal signs are out of order. So this is what I'm going to do. I am going to do substitution. And if you're like, well, don't do substitution, y is not all by itself, or x is not all by itself. I know that. But x is almost all by itself up here. So let me rewrite the top equation. 7x equals negative 21y minus 28. The reason why I'm picking the top is if I were to divide everything by 7, that's going to end up being a lovely number, and that's going to end up being a lovely number. So I like lovely numbers. Let's make it happen. X equals negative 3y equals, not equals, minus, that's a minus sign as you can clearly see, minus 4. See? Minus. Negative 21 over 7, negative 3y. Negative 28 over 7, negative 4. Now that I have what x equals, I did that on the top equation. I'm going to substitute this guy into the bottom equation. X is negative 3y minus 4. So I'm going to rewrite the bottom equation and replace x with negative 3y minus 4. Plus 15y equals negative 20. Distribute. 5 times negative 3y, negative 15y. 5 times negative 4, negative 20. Plus 15y equals negative 20. Now look at what we have. On the left side, negative 15y combines with positive 15y. And you know what happens? You know what happens? They disappear. And what drops on the bottom is negative 20, and what drops on the right is also negative 20. Now, when my variables disappear and I'm left with a false statement, we say no solution. If my variables disappear and I'm left with a true statement, we don't have just no solution. We don't have just one solution. We have a whole bunch of them. And in math, when we say a whole bunch, we say infinite. So in this case, I have infinite solutions because my variables disappeared and I was left with a true statement. Again, if my variables disappeared and I was left with something like 10 equals 20, then I would say no solution. All right, boom, done.